Radius, tangent, and Pythagoras. I was wondering if maybe this doesn't really need a video, because a lot of you will be able to look at these questions and just know what to do because you know radius and tangent and you know Pythagoras. And we're not learning anything new, we're just combining two skills that you already know. Still, some of you might need me to show you how this is done. Maybe you just need to see me do one of these questions, and then you'll be able to do it. So let's just recap what Pythagoras is, because this is something we did a few months ago. Pythagoras said, right angle triangle. If it's not a right angle triangle, Pythagoras does not work. But if you've got a right angle triangle and you're trying to find the longest side, called the hypotenuse, then the longest side squared is the same as the other two sides squared and added together. So you take the squares of the other two sides, add them together, and old man Pythag said, you take the square root, and that gets you the length of the longest side. If you're trying to find the shorter side, so not the hypotenuse this time, not the hypotenuse, one of the shorter sides. Same thing, but instead of adding the squares, you subtract the squares. Okay, so you take the squares of the square of the hypotenuse, subtract the square of the shorter side. Okay, start with the hypotenuse because that's bigger. And then old man Pythag says take the square root at the end, and you've got your shorter side. All right, that's revision. That's Pythagoras. So let's bring this back to radius and tangents. Okay, so circles, radius, and tangents. What does this have to do with Pythagoras? Well, remember what I said in the other video. If I were to give you this question, okay, so not with the circle, if I were to take the circle out and just give you the triangle question, and I said, try to find the other length of this triangle, you can't do it. There's nothing in this question that says that this is a right angle. I haven't told you that this is a right angle. You don't see a right angle sign in the question. It might not be. This is not solvable. You cannot solve this triangle. Now you can, because the circle is there, so you know that this is a radius, and you know that this is a tangent. If that's a radius and that's a tangent, this has to be 90 degrees. Now you know it's a right angle triangle, and now you can solve the question. And the best way to do that is to draw the triangle separately, without the circle, just as part of your answer, as part of your working out. Draw the triangle separately and put the numbers in. So 9.3 here, 12.4 here, and they're trying to get you to find this length here, P to the center of the circle. So give it a letter, doesn't matter which one, letter A. Okay, so A squared equals 9.3 squared plus 12.4 squared. I get my calculator out. (9.3 squared plus 12.4 squared, 240.25. All right. Take the square root of that, 15.5. That's my answer. Okay, so look, it's a Pythagoras question. It's a triangle question. Treat it as the triangle question that it is. The circle is only there to tell you where the right angle is. You're just picking up one mark for saying, oh, that's a circle, that's a radius, that's a tangent, so this is 90 degrees. That's one mark. But treating it the rest of the way as the Pythagoras triangle question that it is, that's the rest of the marks. The circle is no longer important after that. Okay? Give the rest of the questions a go and let me know if you get stuck.